Ruben sir, you are now the co-host, so you can share your screen, sir. Hello, Ruben sir.
Hello, how are you?
Ruben sir, hello.
Yes. Can you hear me?
Yes, very properly.
Okay.
Sir,
I'll just
is
switch
there
off
any?
the fans because the fans are giving noise. I'll just switch off the fan.
You can reduce it. Yes.
And my video is, I'm not permitted to use video channel. I think I can now.
You can, because you can now share the screen, and
Okay.
yes, you have all the rights. Huh?
Okay, fine. I'll just
You
even
are the
log.
co-host, so you have all the rights.
Excellent. Okay.
At this point of time, your stand is working.
You can also ask Ajay sir for help, huh, sir?
Yes, sir is with me.
Yes. Sir knows everything about this, so he can surely help you.
Okay. So just setting up the system. We have hardly 10 minutes, 12 minutes.
No worries. We are already used to this, so if there is any problem, we can sort it out. No worries about it.
Okay, super.
Yes.
Oopsie. Douglas, I'm unable to
Mm-hmm.
see from
You're
my
unable.
laptop. I'm unable to find the settings for this one for presentation.
Presentation. See, there is this at the bottom. There is this green colored icon. Share screen.
I'm not using the installer. My God. I'll have to use the company college laptop. Wait.
You don't have Zoom in this laptop.
In this laptop, I had not installed it.
Okay.
Let me see.
I think installation will not take. We have
Yeah, I'm
Wi-Fi
just
conference too.
installing
So
it also right now.
yes, yes. Hardly in 2 minutes it will be installed.
So if you can call the, so if you can start Zoom on your computer, I'll get this thing over there.
And also, so one more thing.
Yeah.
You have that camera on your right hand side.
Yeah,
Will it be possible for you to keep it in front of you so that you will be
in
seeing it
front of
from?
me.
Yes, because right now it is inclined, na? It is on right hand side.
Is it better?
Otherwise, it will seem
Okay,
that
actually,
like
video is not transmitting from your end.
1 second. Huh?
Yes, yes, please. Much better. Okay. Okay, ठीक है, चलेगा, चलेगा. You got Zoom, sir?
Downloading.
Downloading. Okay.
इसका पासवर्ड नहीं दिखा रहे यहाँ पे सर उनको.
Yes, sir. Any problem?
No problem.
It will not ask for the password because I have given you that ID, so it will not ask for a password.
Okay, ठीक है. So I think you're sharing your screen right now. That is why I'm unable to share it. Do you mind just
Sir, now you are the co-host. Now you can
yes.
share
Okay.
the screen. Now your both accounts are co-hosts, so you can share the screen from both the accounts,
Okay.
both the devices.
जूम हो गया स्टार्ट?
हाँ सर, हो गया।
Okay, sir. Now you're live on YouTube, sir.
Okay, fine. That's fine.
Yes. So just in 2 minutes, we can begin, sir. Hello, Ruben, sir. Hello. Hello, Ruben, sir.
Dr. Thackeray, am I audible clearly to you?
Yes, sir, you are. Yes, sir, you are. Yes. Okay, sir, shall we start? People will keep joining the session. We should start now. It's down. It's time.
Okay.
Okay. Good afternoon, dear audience. Okay. Good afternoon, dear audience, dear participants. I welcome you all to this fourth day of this online internship program on industrial progression of mechanical engineering. So, resource person for today's session is Engineer Ruben Buthello, sir. So, before beginning with the session, I will be glad to introduce him to you. Mr. Ruben Buthello is a mechanical engineering graduate from Mumbai University. Actually, he is Mumbai University topper from Sabu Siddiq College of Engineering in the stream Automobile Engineering, and he has also won the Best Student of the Year award. Mr. Ruben holds a postgraduate degree in management, and he is currently also pursuing his PhD from Mumbai University itself. Mr. Ruben started his career as an R&D engineer with Mahindra and Mahindra, and later on joined Volkswagen as the financial controller for the Polo and Vento models. He has also worked with Asset Motors Mumbai as a junior dealership auditor on the deputation by Mahindra. Then he has worked as assistant manager for reliability engineering. He has worked as assistant manager for CMVR and homologation. During his tenure at Volkswagen as a product cost controller for finance, He has analyzed vehicle costs, material localization cost targets. He has liaisoned with foreign counterparts, identifying and implementing the cost reduction opportunities. Later on, he has started his own ventures. He is an entrepreneur with two entrepreneurial ventures, one in the field of ready-mix concrete and other as a tier 2 supplier to Volkswagen and Tata Motors. He is also active in family business of coach building and operating buses under the brand name Bharat Coach Builders Private Limited. Apart from that, he is also functioning as CEO and partner for Cemix Concrete, about which I told you right now. He is supplier to prestigious building conglomerates like L&T, Kalpataru, Lodha, etc. In Bharat Coach Builder, Sir is mainly involved with new product development such as conceiving, designing, prototyping and manufacturing of new bus coaches and specialty vehicles like armored vehicles, workshop vans, etc. Mr. Rubin has designed and built armored buses for the presidents of Senegal, Tanzania, and Zimbabwe. His organization is amongst the first few coach builders to be certified with AIS 052 certification by ARAI. As a partner for finance and operations of Bharat Fabrication and Manufacturing Components, he is involved with manufacturing of automobile components for Tier 1 compliance. Current clients include Harita Ferrer Private Limited, Bharat Coach Builders Private Limited, and Caparo Engineering Private Limited. He is also involved with designing and manufacturing of edge point machines. So, sir, I welcome you to deliver the session. And firstly, I'd like to thank you to take time out of your busy schedule to deliver this session. So I request you to take the control of the session. And yes, sir.
I thank the HOD of the Mechanical Department, Dr. Ajay
Yes.
Kumar. I thank the management, the principal of the college for organizing this event and giving me an opportunity to share some of the best practices. I won't say the best practices, some of the current industry practices that are performed in a bus coach manufacturing industry. I'm glad many of you all could join here despite the various problems that you all are having at home and the COVID situation that we have. But let us make the best of our time while we are here. I'll just give you a brief overview of what my company does. Bharat Coach Builders is in the business of manufacturing buses for the last 35 years. Our buses are made and exported to over 23 countries. That includes the Middle East, Southeast Asia, Asia, and even South America. We are approved vendors for Ashok Leyland, Bharat Coach, BST, Bharat Benz, and Tata. As mentioned earlier, we were the second company in India to get an AIS 052 approval for over 109 models. Our facility is also approved by the Central Institute of Road Transport, and being on the Bombay quadrilateral, we have a considerable benefit when it comes to logistics. I've just displayed some of the certificates that we have won and the awards that we have received over the years. Now on to the main topic, the main agenda. Today's session, I will be discussing primarily on regulation, on the design process, on how the design process has changed from what it was 10 years back, 20 years back to what it is today, and the various challenges that the industry faces today. So let's start with the first section on regulation. For any bus coach builder, the two primary regulations that one has to follow is the CMVR 1989, that is the Central Motor Vehicle Regulation 1989. This particular act was drafted by the government of India, and it controls every single automobile that is launched, that is operated within the boundaries of India. So if you have a two-wheeler, a three-wheeler, a four-wheeler, a six-wheeler, 10, 12, 16-wheeler, does not matter. All your specifications come, the rules are based out of this very act and these very rules. The CMVR 1989 forms the basic rule. The book is available online free of cost. Anyone can go and download the act and learn the various rules of it. For our industry under consideration, that is the bus coach industry, we have the AIS 052. The AIS 052 is the automotive industry standard. 52 is the series number which had come out, and it relates to the bus body code. Now, the government of India had realized that it takes a long period of time for them to convert any sort of regulation into an Indian standard, into an IS standard. And that is why they contacted the organization ARAI. It's a quasi-government private organization which handles all the affairs of regulation, approval, certification of the automobile industry. And it is this organization, the ARAI, that is responsible for generating automotive standards, which are then accepted by the government of India. So the one that we are interested in right now is the AIS 052, which relates to the bus body code. The bus body code has numerous standards inside, numerous clauses, numerous tests that a bus has to go through before which it can be certified as safe for transportation. There are 94 tests in total on an average, which a vehicle has to go through before it gets certified under AIS. Apart from AIS 052, there are loads of other standards which students have to be aware of. There is the IS 11825, which relates to the dimensions of the vehicle, how big your vehicle can be, what is the allowable length of the vehicle, up to what height can you build a vehicle. If it's a single story vehicle, a normal bus, what is the maximum permissible height? If it is a double story bus, what is the maximum permissible height? All of these points are governed by the Indian standard IS 11825. You have the IS 13942. We have the AIS 065. We have the AIS 23 for seats. We have the AIS 046 for rear view mirrors. We have the AIS 37. There are hundreds of standards that are part of the bus body code. And it is important that everyone goes through these standards, is well versed with these standards, and is able to implement all these regulations in part of your design. So a designing process does not involve simply taking up a scratchbook, taking up a drawing, designing what you have in your mind and putting it on paper, and then finally building a bus according to that. You have to follow each of these standards that have been mentioned over here. And I could go through some of these standards, but each standard is over 200 pages long, and it will take considerable amount of time. So we can leave the standards for another day, but it's just to give you a brief understanding that regulation is important. Without regulation, you cannot build an automobile which is road legal, which can be certified to operate on Indian roads. You can build an automobile, but if you do not follow these standards, you can only use it on private roads or within compounds, not on public transport. With this, we will move on to the next section, which involves design, from thought to design to production. So we'll go through the design process that you need to look into while building any automobile. When we start off with the design, the first thing we begin is with the conceptualization. The conceptualization involves what the customer needs, what are our production capabilities, what do we want to launch into the market, what kind of a product do we want to give our customers in the future. This is what we handle in the conceptualization stage. The next stage involves the illustration. Once we have a fair idea about what the concept we want to bring into the market, we begin illustrating. Illustrating is nothing but the process of drawing, of creating what is in your mind into something tangible that someone can see. So after we create the basic concept of what we want, we get an artist to come and draw what we require. He prepares a drawing, a painting of a bus, and that bus is used as a display to give to our clients. Our clients look at these designs. If they like it, they approve it. If they do not like it, they ask for certain changes. We make the necessary changes, go back to them, and we get an approval for the bus. After the illustration part is done, we then move on to the CAD model. Here we design from the previous stage involved an illustration, basically a drawing which was created by an artist. However, this artist may not be technically qualified. At the CAD model stage is when the technical validation happens. We have to also ensure that whatever rules are there have to be adhered to, they have to be followed, and all of this happens in the CAD model stage. Once the design is ready and frozen, it is sent for computer-aided engineering, where we give it to rapid prototyping and the first prototype is made. Now, what we will do in the next pages, we will go through each of these sessions, each of these stages one by one, and we will try and get a better understanding of how these stages are practically done in a factory. So first we will begin with the conceptualization, the very first process, conceptualization. The conceptualization is broken down into 4 major areas. The first area is customer preference, second is benchmarking, third is cost efficiencies, and fourth is production constraints. So let's look at what is customer preferences. Now, there are already buses in the market. Customers like some of these buses. Customers do not like some of these buses. So it is our job to understand what are the features that the customer likes, what are the features that the customer dislikes, what are the features that the customer is willing to pay a premium for. Is there some feature that he is not getting in the competitor that we need to include? These are the type of decisions that we need to consider during the customer preference stage. So luggage space, front show, seating capacity, how many seats can fit in the bus, how much space is available, how much headroom is available, does he have space to charge his phone, does he have a place to hold his phone, a lot of these concepts, how big are the windows, a lot of these things which are important in terms of the design, in terms of features are taken from the customer side at this stage. The second thing we do is we do a benchmarking. As you all are aware, benchmarking is a competitor analysis. We try and analyze what our competitors are offering to the customer at a particular price point. So if it is a regular staff bus, which is given by Tata or Ashok Leyland or Aisha or some of our other coach builders, we try to ensure that we are offering similar features for a lower price or better features for the same price. So our entire goal of benchmarking is to find out what is in the market, what is the competition offering, and how can we offer something which is better than what the competition is offering. So at the conceptualization stage, at the very initial stage, we first look at what the customer needs. We look at what the competition offers. The third we look out for is how we can reduce the costs, how we can reduce the technology required, the manpower required, the machines required to put the bus together so that the cost is reduced and the benefit can be passed on to the customer. So we do this in the following ways. We try and ensure we can combine certain parts. If we can have the entire bus erected much faster, much quicker, much easily without too much of effort, it'll definitely reduce manpower cost. It'll reduce the time for assembly and it'll improve the margins for the bus. We also ensure while designing, if we can commonize, if we can standardize a lot of the parts across different platforms, across different models. So for example, the doors in all our buses are nearly identical. The emergency doors, the hat rack, the dashboards, we've tried to commonize. So a lot of the features of a bus, which are common across various buses, we try to commonize them so that we get economies of scale, economies of scope. That is one of the requirements. And the next final requirement while conceptualizing is the production constraints. It is good to dream, it is good to imagine new features, different features. However, if there is a difficulty in manufacturing these parts, then we will always have a problem. We will not be able to maintain our cost targets. We will not be able to maintain our quality targets. We will not be able to maintain our customers' expectations. So we have to keep in mind what are our production constraints, what are the problems at the production level that we will face due to which we may have problems later on during production. So just to give you an example, laser cutting, a simple concept as laser cutting. In Bombay, there is no laser cutting machine which has a length of more than 3 meters. So if you want to cut any part with more than 3 meters in length, you have to move out of Mumbai, go to Pune, go to Chennai, and only those places have large laser cutting machines. Going to such cities, out of the city, manufacturing, bringing them back adds to cost. And this is the cost which the customer may or may not want to bear. The same goes for CMM testing, coordinate measuring machines. You build a part very accurately. However, if you want to measure it with a CMM machine, there are no such machines available in Mumbai. Again, you have to move out of Mumbai, find a vendor in another city, get it done from there. There are also certain durability constraints that you have to keep in mind. Durability is nothing but how long a product will last. There are some parts which can be made to look very beautiful. There are some parts which are very shiny. There are some parts which have high gloss. However, these parts may not be suitable for the bus industry as the users of the bus industry may damage them over the course of the lifetime. So whenever we put any part in the bus, if we design a part which has to be used on the seats, on the interiors, on the flooring, we have to keep in mind whether it can sustain the vibrations in the bus, the jerks, and the various accelerations, decelerations, the various scratches that occur on the bus, whether people walk on it, whether they will intentionally or unintentionally damage those parts. All of these things have to be taken into consideration before designing, before conceptualizing a part. Once you take all these four concepts into consideration, you have taken your customer preferences, you've ensured that you're offering something better than the competition, you are ensuring that your cost is within the budget that you have allocated, and you have ensured that your production, you can manufacture all of these parts that you have thought of. You then you get an outcome, you get an output, which is called as a specification sheet. The specification sheet is nothing but the sum total of all the features, all the parts, all the bill of materials that will go into building a bus. So with this, we are able to complete the first stage of our design process, that is conceptualization. We'll now move on to the second stage of the second stage of the design process. The second stage of the design process is called illustration. Once you have a fairly good idea about the kind of features you want in your bus, the various parts that are required in the bus, you then move on to illustration. For illustration, we typically hire an artist. The artist has a background in product design. Usually it's a person who has done his course from the National Institute of Design, or Institute of Design from JJ Arts, or it could be Gujarat related design studios. So we had told of one of these gentlemen. They come over and they begin converting our dreams, our ideas into something very practical, something into very visual, that we can then show our clients, that we can then show our designers, that we can then show our production in charge, to get an understanding whether this is possible or not. So what you see on your screen right now is one of the first impressions that the artist has made. He's made this as one of our concept vehicles that we had designed for one of the auto shows. Unfortunately, we didn't have time to present it at that time. However, this is one of the target vehicles that we intend to build in the future. Once you have the illustration, we can then go about making fine details, fine changes into them. I will show you by what I mean in the next few slides. The illustrator also gives out various options on how your front show will look. In this case, if you notice, there are various shows, there are various design possibilities available. All of this can be easily done with a touch of a stroke on the computer without too much of hard work. With these designs, with the illustration, we can show our client, we can show the end customer, we can show our designers, we can show our production people what the final bus should look like. What are we aiming to get? And this also helps our clients make a decision. Looking at these designs, the client can then choose which design is most suitable to him, which design has the best market appeal, which design may be most successful in getting us sales in the market. After the illustration stage is over and the client finalizes a particular design, we then move on to the next stage. The next stage is converting these designs into 3D data, into actual production, mechanically, technically competent designs. This is where the 3D modelers come in. The usual software we use for this is the one that we have in the company is Siemens Unigraphics. We also use AutoCAD for smaller drawings, but for vehicle level drawings, vehicle level modeling, we go for Siemens Unigraphics. It is at this stage we need to keep three things in mind. What are the various regulations? What are the technical feasibilities? And what are the cost feasibilities? So this is where all the knowledge that you have gained earlier in the regulation side, the various tests that are required, they come into consideration. You also have to get the production in charge people to be part of this, because they need to tell you whether what you have designed can be finally manufactured or not. Very often we may have fabulous designs in our mind, but it may be simply too expensive, it may be too difficult to produce, or it may not meet regulation. So this is what we need to keep in mind before we start the CAD model process. I'll give you an example. In the original illustration that you had seen earlier, the maroon color bus, I'll take you to that. If you look at the windscreen has a very smooth curve to it. It bends towards the edges, and it's very attractive to look at. However, when we did go to the glass manufacturer with the design, he told us that it's very difficult for us to manufacture the glass. There will be a lot of problems while installing the glass, and there will be a lot of breakages during the lifetime of the vehicle. Taking that into consideration, we had to rework the design. So the curvature of the glass had to be modified to better suit durability requirements. It was modified to better suit manufacturing ability. It was better suited to ensure that it can be mounted on the bus very easily. So in the technical feasibility, we had to change the curvature. There were a lot of the design that you had seen earlier by the illustrator had a lot of nice features in them, a lot of contours as we call them, or nice shapes to it. However, we soon realized that many of these shapes are too expensive to manufacture, and it is simply not worthwhile. So we had to tone down, we had to remove some of the features to ensure technical and cost feasibility. Another consideration that we had to do was, I'll give you a small example here, is for the windscreen. The regulation AI 052 suggests that the windscreen your windscreen wipers has to wipe out a large area of your windscreen. So the bigger the windscreen, bigger the area you have to wipe, and that is a challenge for technical. It is difficult to technically clearing such a large windscreen with 2 windscreen wipers. Hence, those designs have to be modified slightly too. Headlamps also, we realized that the small headlamps that we had in our initial design were incompatible with our lighting requirements for AIS 52. Hence, once again, we had to change the lighting setup. Doing all of these modifications and trying to adhere to the regulations, trying to match technical feasibility and cost feasibility, we finally came up with the file that you see to your right. The model that you see there is what we finally made it. And this model was finally given for CAE, for computer aided engineering. With Unigraphics, with Siemens Unigraphics, we usually create a step file, a .stp file. This .stp file can be easily read and by rapid prototyping by manufacturers so that they can tweak it, modify it slightly when required. And it is a language which is very easily understood by their 3D manufacturing machines. So with this, we complete our CAD model stage and we then move on to our CAE stage. In the CAE stage, which is computer aided engineering, we most typically go for rapid prototyping, which is under 3D printing, additive type. So we give them the input in the step file. We've created, as I told you earlier, we first design it, we render it on Illustrator, we convert it into a 3D model. We ensure the 3D model fulfills all the requirements of regulation, technical, and cost. Once this is done, a step file is created. You can, with the step file, there are loads of 3D manufacturers across India. You can visit any one of them, just email the step file to them, make the payment online, and they will post the material to you. Since our parts are fairly large, obviously they cannot post it. We send a truck to pick up the patterns and come. Once the 3D printing part is ready, we give it to a pattern maker. The part which comes out in 3D printing has rough edges to it. It is not as smooth as what we want. There are scratch marks on them. There are unintentional burrs on them, holes, pit holes, which all need to be patched up. They need to be smoothened out. They need to be touched up. And that is how we have sculptors and painters who come working on it and they create a pattern. If any of you all have studied mold making, you will understand the word pattern and mold. For the rest of you all, I request a little background reading before you look this up. Once you have the pattern made, we can then start making the mold. The mold, we use molds for 2 processes. One is for fiberglass and the second is for glass template. So the front windscreen and the rear windscreen, these are glass templates. We use the pattern. Once the pattern is ready, we send it out, we ship it off to the glass manufacturer. The glass manufacturer uses the pattern that we have given him as the base template. And from that template, he will manufacture the final glass, which then comes to us. Similar process for fiberglass molding. The entire front show, the entire front of the vehicle that you see, is made of fiberglass. It is a very durable material. It has a very long life. It gives you very good finish, and it does not rust, most importantly. It's one of the ideal materials, a great material which has been introduced to bus body building. And fiberglass manufacturers require a pattern to be given, and through rapid prototyping we can give them a pattern, and they make use of it, and they are able to give us the final product. With this, we finish the CAE part of it, the computer aided engineering part of it. I will take you through the next step of what happens from concept to production. So on your left, you will see the concept vehicle that we had in mind, and on your right is the final production vehicle that comes out. As you can clearly notice, a lot of the features of the concept vehicle were not ready to be put in the production vehicle because of cost restraints, cost constraints, because of production feasibility, and many few other reasons. However, we do hope that in the future, we'll have an opportunity to take more of the features from the concept and incorporate them into our final vehicle. This is an ongoing process, a continual improvement process, but we are sure that over time we will reach the concept designs that we have in mind. Now what you have here is how we used to design and render our models in the past. On the left hand side, you have drawings of 3 vehicles, and you have 3 different painting options that have been given to it. In the past, when the customer came to us and they said, how will my bus look? This is what we would normally give them. We charge a small fee for the drawing and the painting fees, but at the end, we would be able to give a customer a fairly rough idea about how their bus would look, what would be the approximate shape and size. To your right, you have the 3D rendered models that we offer today. So today, when you walk into our company, for a small fee, we can offer you exactly how your bus will look after production. So we can visualize the entire thing, offer it to you with dimensions, a scale model, so that you have a close understanding that if this is the idea you have in your mind, we can convert that into reality, of course, taking regulation, technical and cost features into consideration. I will also, with the next section that I'm going to touch upon is the old versus new. Here particularly, just a second. This particular model is is the kind of buses that we would normally manufacture 10 years back, 10 to 15 years back. A few features of the bus are as follows. If you notice the front glass, I have highlighted there in yellow. The front glass is a flat glass. It's a laminated, flat, plain glass, 2-piece glass. They are easy to manufacture. They are low cost. They are easy to mount. They have a fairly good life. However, they are not very attractive to look at. If you look at the second dot which has come up, it is the aluminium bidding which is used to cover the front of the vehicle. This third dot is a simple aluminium sheet which is used to cover the entire front fascia. These are standard grills which are available along with the chassis, which we have retained and have modified as the front of the vehicle. And headlamps, very simple basic headlamps which come along with the chassis. Same headlamps are mounted onto the vehicle, and a regular steel bumper. If you look at all these features, these were the features common in almost every bus which was sold right up to 2005. All buses follow the same basic principles of design. They had the same flat glasses, aluminum putties everywhere, simple aluminum sheets in the front, steel grill, regular either round headlamps or square headlamps, very hastily mounted on the front grill, and a very simple steel bumper. This was because the techniques we used were very traditional, very old, and that is why the result which came out also was very basic in nature. However, using the techniques which I've showed you in the previous slides, from Illustrator, from conceptualization to Illustrator to CAD to CAE, we can now create buses which are like this. If you notice this particular bus that we have built, this particular model is for the Dubai markets. It is exported to the Middle East. If you look at the glass has a nice contour to it, a nice smooth shape. It offers very high visibility to the driver. So it increases the safety for pedestrians as well as the occupants of the bus, the passengers in the bus. If you look at the front show, it is very beautifully crafted, a lot of contours to it. It has its own distinct persona for the grille. The headlamps are very beautifully designed, encased in a nice molding. The bumpers are not steel regular bumpers. The bumpers are part of the front show itself. It is integrated into the design and it is easily replaceable. It also, if in case of damage, you can easily repair it. A lot of benefits, features which have been added to it. And it is a considerable, a giant step compared to how buses were built just a few years ago. And all of this was possible thanks to the modern techniques of illustration, CAD, CAE, and a little hard work. Let us look at the process. Let us look at the tangible benefits that we have received as we have moved from the old concept to the new concept. In the old concept of designing, we would first create a draft concept, a draft specification. Once that is ready, we would give it to the tin maker. These are specialist workers who are very good in sculpting out of sheet metal. Once they prepare the design is given for finishing and for painting. So the painters will come, they'll finish all of this. And with the finished prototype, we would then call the customer to approve what design we have made. Unfortunately, if the customer does not like the design, he will send it back. He will ask us to rework upon it. And the entire process would take over 90 to 120 days. So anything from 3 months to 4 months for us to design something, to create a first prototype from it, to give it to a customer, get his approval, and then to finally take it up for production. 190 to 120 days, a very lengthy process. However, with today's modern techniques, we are able to go from conceptualization to illustration to customer approval, because we have now illustrated this. We have now shown it to the customer. We can show it to a customer how your vehicle looks, how it will be as a finished product. We can get his approval right at the start. We don't have to form a feedback loop, go to the end, come back to the start. All of that is avoided. You get the approval at the second stage itself. From there, you go to CAD manufacturing, go to CAE, you go to the proto development, and the entire process is completed in 20 days. So you see, this offers tremendous benefits in terms of cost saving. It offers tremendous benefits in terms of productivity and time saved. We can now get the product ready into the market much quicker, much faster. A lot of true revolutions have happened in the industry over the last 10 years. CAE, computer-aided design, has become cheaper. You have a lot of skilled technicians. You have a lot of skilled engineers who work on CAD. You have a lot of skilled, you have a lot of options for manufacturing whatever has been designed. So you design on a computer, you take it to the vendor, he will manufacture the part to you, bring it back, slap it onto your prototype vehicle, and your bus is ready in no time. These are some of those important tangible benefits that we have received over the last few years. I will now move on to the last, second last section of my talk today, the challenges in the industry. The industry is good. However, as in any industry, there are a lot of challenges which one has to face. The first one is the number of parts. On an average, each bus requires 1,500 parts. Without these, even if one part is missing, your bus will be incomplete. You will not be able to manufacture the bus. So keeping inventory of these buses, keeping inventory of these parts is a major challenge. The second challenge is linked to the first one. We currently have around 109 bus models, and every day we end up adding one or two, not every day I would say, but every month we end up adding a model or two into the inventory. This is a big challenge. So if you combine 1,500 parts with the 109 different models, our total inventory in the factory becomes 6,000 to 6,500 parts. So at any given point of time, we need to keep a stock of an inventory of over 6,000 parts, which is a big challenge for storage. It is a big challenge for inventory. It is a big challenge for cost. It is a big challenge for after sales support. Because suppose we build a bus 5 years back, 6 years back, and the glass breaks. You need a replacement glass. We have to ensure that a replacement glass is kept in a factory readily available to supply to the customer. If the seat is broken, seat tears, if a fabric is torn, if a handle breaks apart, any of these small components, if they are broken, we have to ensure that the part reaches the customer within a day or two. And this is one of the growing challenges. So having an ERP system which can meet these requirements of creating a bill of materials, of maintaining inventory, of blending the two is something we are currently still chasing. We have tried a few products in the market, a few ERP products in the market. However, we've noticed that they are not up to the mark. They either are extremely time consuming or they are extremely complex to operate for a mid-sized company like us. And the ones which are too simple do not match our requirement. They are unable to even perform basic tasks. So we are in this mid situation where we are in trouble trying to manage inventory, trying to manage parts. But we are hopeful in the next few years, some company will offer us a product which can better suit our need. The next challenge that we face is the shortage of labor, of skilled labor. Today's day, a welder does not want his son to be a welder. He wants him to be an engineer. A painter does not want his son to be a painter or his daughter to be a painter. He wants them to be an artist. A finisher, a man who finding a trim operator, does not want his son to be there. He doesn't mind him being in the accounts, working for a large multinational. And this shortage of labor is going to be fairly acute. It is going to get even worse in the coming years as we are finding dwindling skilled laborers into the business. One way in which we are trying to address this challenge is by taking out all the skill at the production level and moving it to the design level. So what we are trying to do today is all critical jobs which require skill have been eliminated at the design stage, and items which can be easily manufactured or outsourced are what are being created today. So that is how the industry is trying to survive with the current challenge. And the last and important issue with the current situation is the erratic demand. I'll give you an example. School normally starts in the month of June in India, across India. 2 months prior to the start of school, we get a lot of demand for school buses. So for the months of April and May, our company is flooded with orders for school buses of various sizes. Soon after June passes and July begins, all the orders die out. There are no more orders for school buses. A similar situation happens in the month of October and November. You have a lot of demand for luxury vehicles, for staff vehicles, because the new year is beginning and people want to register their vehicles on the on January of the 1st of Jan, in the first month of the new year. And you have a lot of demand during the last 3 months of the year. The moment January hits, the demand falls considerably. So you have a very erratic demand cycle which follows the industry. Certain months of the year, there is a lot of order. Certain months of the year, there is very little order. This is one thing which the industry is constantly challenged by. We are part of the industry. There is nothing we can do to avoid it. And the only option that we have is to mitigate it, to reduce it, is to find alternate markets where we can move to, where the demand is high during non-peak time. With this, I have completed my session, and I'm now opening the forum up for anyone who has a question. You all can post your questions in the chat section, in the comment section, and we will try and answer the questions that you all have. Thank you.
Thank you, sir. That was a very precise yet very detailed and comprehensive presentation. These are not my words, actually.
Sir, one second, sir, I'm unable to hear
yes,
you.
Please. Yes, sir.
Yes, sir.
Am I audible now?
Yes, sir. You are audible now. Yes.
Okay. Okay. Sir, actually, people have appreciated the presentation that this is a step-by-step in detail explanation of the good work.
Oh,
and they find it very interesting, as well as let's say that Rajkumar sir is saying that the procedure has been explained in nutshell. So the people find this presentation to be useful, sir. So now
thank you.
I request the audience that the platform is open for doubt clearing and question and answers session. So I request you to post your queries and doubts in the chat box, which is available with YouTube platform. So, sir, the first question is from Vivek Pandey, sir. What are the
Okay.
safety standards of a vehicle?
Safety standards. There are multiple. There are 94 tests, as I mentioned, to conduct any to have any vehicle approved and certified for Indian roads. I'll give you a few basic ones which are there. There is something called as the rear underrun protection and the side underrun protection. These are IS 11394, I believe. What this talks about is between the two tires of the vehicle. If you look at the rear of the side of the vehicle, there is a panel which extends 300 from the floor of the from the ground. This panel is used so that in case a biker or a car hits the vehicle from the side, the vehicle should not enter into the rear of the vehicle. It should be safe from falling under the wheels. So we have these rear underrun protection. Same we have the side underrun protection. Similarly, we have for the rear side also. Another example is the laminated and toughened glass. The normal glass that you have for domestic purposes, for your windows or for your cookery, they break very easily. However, the front windscreen of the glass, the front windscreen of a bus is made of laminated glass. What do I mean by laminated glass is there are two pieces of glass, and between the two pieces of glass, there is a layer of plastic, a very hard I think it's PVC plastic, which is there, which is extremely tough and hard to break. In the event of an accident, none of the glass pieces will hurt the passengers, nor will they hurt a pedestrian. Another safety aspect that is taken into consideration is rollover test. Any bus which has to be designed and approved has to undergo a rollover test. The test involves tilting the bus on its edge and ensuring that the bus topples over. And after it topples, a test is done to ensure that the passengers inside the bus are safe. It's a fairly complicated standard. It comes under AIS 031. If anybody is interested, they can go look it up online. It's a form of a crash test. Luckily, the ARI organization has allowed this test to be conducted virtually on CAE also. So ARI will do the test for you and they will offer you a certificate. There are hundreds of tests related to this, similar to this. We could go, it would take a lot of time, but due to paucity of time, I think I'll keep it up to this. But if you want further information, you can visit araiindia.org. This is the website of Automotive Research Association of India. In that, you have a section for downloads where you can download any of these standards. They're all free of cost. You can go through the standards, study about it, and take note. One very important standard that that is relevant for the automobile sector is the IS 15062. This relates to flammability. The standard says any material that is being put in the bus, except for diesel and oil, should be flame resistant. What do I mean by flame resistant? It means that if I apply flame to the part, and after I take out the flame, the fire, and the part does catch fire, the fire should self-extinguish within 5 seconds. So the fire should not spread. And we've been successful in ensuring that almost every part going into the bus is flame retardant. Hence, there are very few cases of buses catching fire in the event of an accident. These are one of the major improvements which have happened behind the scenes where the public has rarely come across. And we are going, it has been fairly helpful for saving lives. I hope this has answered the question.
Okay. Yes, sir. Because all of them were related to safety of the vehicle. So the next question. Yes.
So if you can ask in related to safety, if there is something more specific, I can then dive into that and I can give you a more clearer answer towards it.
Okay. Let us ask Vivek Pandey, sir, if he wants to know anything more about the safety.
All right.
Until then, while he posts his question, we'll move on to the next question.
Yes.
Question is from Mr. Sarvesh Gharat. What kind of employment is generated by your industry?
The industry. See, as I mentioned, we in the inventory of our company, we have around 6,000 parts. 6,000 parts are required to make the different models that we use. Out of these 6,000 parts, maybe 500 to 600 parts are made by us in our factory. We have around 250 employees in the company who work with us. So you have you have the production line people, you have manager, you have supervisors on top of them, you have a manager, we have design engineers, we have storekeepers. These are all of these involved in manufacturing these 500 parts and the bus assembly together. However, there are 5,500 other parts which are manufactured by other vendors across India. These include seats, they include glass, they include aluminium, they include sections, they include Rexine, they include grab handles, plastic components, ABS, PVC parts, PP parts. There are hundreds and thousands of parts, steel related, galvanized iron, paint related parts, and all of these industries are interlinked with us. So since it's a form of indirect employment that is offered from an OEM like us to other smaller tier one companies out there.
Okay, sir. Okay, Ms. Maya Kapde ma'am is asking,
Yeah.
sir, we would like to know about standards the vehicle is to be designed.
Okay. There are no standards on to how a vehicle has to be designed. I'll tell you, the design wise, there is absolute freedom. You can do whatever you want. However, there are a lot of safety related standards which come into play. I'll just give you a brief about this. For example, dimensions. When you talk about design, there'll be constraints. So one of the CMVR constraints, the Central Motor Vehicle Regulation constraint, says is that no vehicle in India can be wider than 3.5 meters. That is like one of the important constraints. It also says no vehicle in India, no bus can be longer than 12 meters. So that's another constraint. It says the headlamps, your headlamps cannot be higher than 800 mm from the ground. That's a constraint. You need to have two sets of headlamps which are not more than 400 mm from the side of the vehicle. That is another constraint. So there are a lot of these type of constraints which are integrated into the standard, and unless you follow each of these regulations, you cannot design your vehicle. So they have not directly controlled your design. They have controlled the standards, which indirectly will control how you design something. So vehicle dimension is one of them. Another one which is fairly important is interior fittings, AIS 047. So that governs what type of materials you can use on the interior of the vehicle. For the same reason why you cannot use marble. The hardness of marble is so high that it will not pass AIS 047 standard. Hence, you can never have marble or granite inside any vehicle. That is why you will never see your dashboard made of marble or your flooring of a car which is made of marble or granite. Simply won't happen because it's simply too hard to pass any of the tests over there. So although they have not constrained, they have not given a restriction, don't use marble, don't use granite. The standard is designed in such a way that you are restricted to go for certain materials which will pass your test, and you cannot use certain material which will not pass the test. I hope that has been able to I've been able to answer that.
That will act as a guideline for the further design. Yes, they can
Yes.
explore afterwards. Yes.
It's a guideline over which yes, they can you can work with.
Yes. So next question, actually, firstly, it is appreciation and then it is followed by a question.
Yeah.
From Mr. Akash Bidkar. So thanks
Okay.
for a great presentation, sir.
Thank
Then,
you. Thank you,
yes.
Akash.
Yes. What is the percentage of total cost which is spent on aesthetic only?
On aesthetics. See, now when we say aesthetics, it is see a bus typically has various sections. So the first section is your skeletal structure, your superstructure. Your superstructure is made of galvanized iron, or it can be made of aluminium, and then you have your skin panels. Now your structure, your aluminium and skin panels are the skin panels form an important part for design. Your structure does not. Then another important aspect is your paint, what kind of paint you use, whether it is enamel type, it's epoxy, or the latest that we use for all vehicles is the PU paint, polyurethane paint. Um in them also you have various options. You have solid colors, you have metallic colors, you have clear coats, base colors, loads of other things on them. Then you have the fiberglass front and rear portions of the vehicle. Then you have in the interior of the vehicle, you have a lot of ABS components. ABS is the kind of plastic that you have today in cars. Your dashboards are made of ABS and PP, polypropylene, or PC, or PVC, and Rexine. There are a lot of things which go inside. But so it is very difficult to say that this part is only for aesthetics or not for aesthetics, because these are all design elements. All the design elements come together, and that is how you make a good looking bus. So if I start counting all the design elements that make a bus, a typical bus will be around, a staff bus, non-air conditioned, will be around 7 lakhs. So I would say the paint, the skin panels, the interiors, they all account to maybe around 2 lakhs to 3 lakhs as such. That will go towards the cost of the parts. Yeah, something on those lines. 2 to 3 lakhs.
Okay. Sridhar sir is asking, sir, if I am buying one normal bus,
Yes.
you are building coach, then
Yes.
how much is the minimum cost of it, and what are different types of coaches?
Okay. I will see there are various types of buses that are available in the. I'll start with that. Various types. I'll start with the end part of the question, and then I'll go to the other parts. There are various types of buses in the market. The AIS 052, the bus code of India, states that there are categories of buses. There is a type 1, type 2, type 3, and type 4. Type 1 is all the other intra-city passenger transport. Okay, intra-city passenger transport, like your BST or Navi Mumbai municipal transport, or your Vasai Virar municipal transport. Those type of buses are called as intra-city buses, where majority of the people are standing. There are few seats left for people to sit also. Just give me a second. Type 2 is your intercity transport, intercity state transport. These include like your Asiad buses, your ST buses. They have minimal standing. They offer few people to stand, but primarily they are seating type of vehicles with very bare minimum of comfort. That is your second level of buses, type 2. These buses are also the types which I normally use for staff buses and for school buses. There is a second type of category. Type 3 type of buses are your intercity luxury buses. Now, these buses are the ones that you normally see on the highways. You have a lot of players in the market like Volvo, Scania, MAN, companies like us, Bharat Coach. All of these companies operate intercity buses. Primarily, you will find them with AC or non-AC, and yeah, that comes under type 3. And the type 4 category are all special purpose buses. The special purpose buses include sleeper buses, they include armored buses, they include medical vans, they include school buses, double-decker buses. All of these come under type 4. So you have these four broad ranges of buses, and depending on what type of bus you choose, the prices vary accordingly. So a type 1, a typical type 1 buses like your BST bus will cost you something around 8 lakhs to 9 lakhs. Type 1, type 2 are almost the same pricing. Type 3, the luxury buses go to around 12 lakhs. And your type 4, it depends what type of bus you're buying, because the scope is so wide, the prices go all over the place. And yeah, it's it'll be depending on the kind of vehicle you buy. Now, here is something very surprising and very interesting I'd like to share with you all. If you look at the chassis cost, normally the way our industry works is the chassis, that is the longitudinal member with the engine, driveline, wheels, that we take it from a company, from any of the companies like Tata, Leyland, Eicher, or Bharat Benz, and we make everything else that you see on top of it. So like the structure, the panels, the glass, the electrical fitments, the seating, interiors, the paint, the finish, everything is what we do after that. Now the cost of a chassis, okay, just the plain chassis has increased from say 7 lakhs to currently, if you go to buy a chassis, Euro 6, Bharat Stage 6 chassis, it is around 33 lakhs. Okay, so the jump has gone from 5 times, 500%. It has increased. However, if you look at the bus coach costing, that has only increased from say 3 to 4 lakhs. Maybe 20 years back, it has come up to around 7 to 10 lakhs as such. So the jump over here has been hardly 200 to 300%. There has been a considerable. We have, due to the points which I mentioned earlier, in how we have started using rapid prototyping, how we have used modern techniques to reduce the cost of development. We have been able to control the cost of the body. However, on the chassis front, unfortunately, that they have not been able to maintain those costs, and the costs have just been spiraling out of control. And with the introduction of Euro 6, that has created a tremendous disturbance in the market. Costs of chassis have gone up by 5 lakhs on an average, and compared to Euro 4 chassis and Bharat Stage 4 chassis, sorry. And this is creating quite a bit of turmoil. Thakre sir, I hope I have answered his question.
Yes, sir. Okay.
Okay.
Shall we take the next question?
Yes, of course.
Actually, people are so much interested in this. So many questions are lined up.
Oh, okay, that's nice.
Actually, when you answer one question, already 3 questions are there in line.
Yeah. Oh, that's good. That's good. I'm glad people are asking questions. Yeah, we can continue this.
Yes. Then, okay. Mr. Abad Pathan is asking, is there any specific audit officer present in the whole process for inspection?
Yes, Abbas Khan, good question. Very important question. We have two sorts of audits which happen. Yes. We have, I would say, three sort of audits which happen. Three types of audits happen in a reputed company. The first one is the internal quality. We have a quality engineer who is on our payroll, whose job is to go through the various stages of manufacturing. He is involved right from the design stage. So at the design stage itself, once the design is frozen, he will mark out all the important and critical dimensions which have to be maintained. He will mark all the fit and finish important quality aspects which have to be maintained. He will ensure whether the paint quality is being as per customer requirements. He will ensure whether all the safety equipment that have to be put on the vehicle are being done. He will also ensure once the vehicle is ready, a road test is done, a shower test is done, underbody protection is done, and fit and finish and all electronics, whether these systems are working or not, all of these tests are controlled by the internal quality engineer. That is his responsibility. And all of it he handles. We have a checklist. And I'm glad to tell you that very recently, we moved all of these checklists to Google Forms. So earlier he would have to go for every bus, pick out the old form, tick mark on them, all the important points, then go and file it back again. Now all of that is done on the mobile phone. He opens up Google Form. In Google Form, he searches, puts a job number, and he puts in all the quality points that he has observed, any mistakes, any issues, all of that are recorded in the system. And we take action based on that. So the first level of quality check happens internally. The second level of quality check happens from the client side. As I mentioned, we are authorized manufacturers for Ashok Leyland, for Eicher, and for Bharat Benz and Tata. So at any given point of time, we have at least one or two of their engineers stationed in our company. At this very moment, we have Mr. Bhupendra Singh, who is part of Ashok Leyland, who is an Ashok Leyland employee, who looks after their quality department, who is stationed at our place. His job is to oversee and ensure that whatever quality points we have mentioned are being followed or not. So we have our internal system, we have an external system from them also. The third level is the government side. So ARAI, every time we go for a self-certification from ARAI or from CIRT, we have their engineers who will come, who will validate the design, who will cross-check whatever we are doing is as per specification or not. As of now, because the bus coach industry is a very small industry, it is not a very matured industry. That is why the rules are not very strict. But over time, what we are seeing is the rules are getting stricter and stricter by the day. And since we are already following all of these processes, for us, it is not a bigger problem. But we are happy that it's moving in the right direction as such. So as I mentioned, we have three levels of quality check. First, internal, second from the client side, and third from the government side. I hope I've answered your question,
Yes.
Abbas.
Yes, sir. Next one is from Mr. Shubhankar Bhate. Yes, it's very interesting actually.
Yeah.
Sir, as you said that your company has designed bus for Dubai market.
Yes.
So did the company had to change any of the design standards or not?
Yes, Mr. Shubham, good question. Dubai comes under the GCC, that is the Gulf Cooperation Council. So you have Saudi, no, I think Saudi is not part of it. You have Kuwait, Qatar, Abu Dhabi, Dubai, Ras Al Khaimah, and all these Gulf cities which are part of the GCC. And the GCC has developed standards for buses that can be sold in these Gulf countries. So whenever we design a bus for a country like that, for any of these countries, we have to ensure that we follow the GCC norms. Luckily, the GCC norms are not as stringent as the Indian AIS 052. The AIS 052 is at least 3 times more stringent than what the GCC norms are. And since we all the tests that we have, and the good thing is both GCC and AIS, I believe they have some sort of understanding between them. So our certificates are valid there, and certificate compliances which are related to AIS 52, which are applicable here. If you've done the test in GCC, they are valid over here also. So it becomes easier for someone who has done AIS to penetrate those markets. And fortunately, we had already gotten our vehicles passed as per their standards years ago. We developed the Dubai market nearly 20 years back, 15 years back. So Ashok Leyland, we were building buses for Ashok Leyland, and Ashok Leyland became the dominant player using our buses in the Dubai, in the Middle East market. So we learned from the experiences we learned over there. It became very easy when AIS standard was introduced in India. It became easy for us to comply with the standard and to get our vehicles passed over there. So we do the same. We send vehicle. We have sent vehicles to 23 different countries, and in each country they have their rules. And before we manufacture, as I told you, in the conceptualization stage, at the very first stage, we look at customer requirements, and in customer requirements, we have to ensure that what we build is as per regulation, is as per the customer needs. And yes, we do that. So there's a lot of paperwork involved, a lot of reading involved. Primarily, it's my department which handles that. So it's me. I have my teammate, Mr. Uzair Ibushe. The two of us are the ones who work on the regulation part. And my benefit was when I was working with Mahindra and Mahindra, I worked for the Department of CMVR and Homologation, Central Motor Vehicle Regulation and Homologation. So I was already used to a lot of these regulations. I was used to reading documentation. I myself participated in creating a few of these standards. So yeah, it becomes easy for us to build a bus now because of my past.
Remarkable, sir.
Thank
Okay.
you.
Yes. Now we have next question from Mr. Vinod Surange, sir.
Yes.
His question is, what are the key challenges in Industry 4.0 technologies implementation? And where do Indian industries stand in the context of fourth industrial revolution? Your opinion as an industry expert for your particular domain.
Aja, we have been lagging behind in when you come. I think we are still in the not even in the third industrial revolution. We are somewhere in the second 2.5 of the industrial revolution in the automobile sector. Um, one evidence, not, and this is not only me. It is the entire automobile sector in general. If you look at what has happened to by what Tesla has done to the automobile markets in the US and Europe and in China now, is exactly this. Tesla was no one. Okay, he was nothing a few years back. Elon Musk out of nowhere has come, and he's become the most valued automobile company in the world. He has beaten the Toyota family, which runs Toyota Motors. He's defeated the Porsche family, which runs the Volkswagen group. He has defeated the Ford family, which runs the Ford Motor Company. He has defeated General Motors, which was the largest in the world at one point of time. All of them he has beaten in a heartbeat as such. Why? Because the entire industry was sleeping. We've been caught with our pants down. If the very same IC engine which was developed by Rudolf Diesel maybe a century ago, 100 years back, is the same diesel engine that we are using today. Nothing has changed. It's the same compression CI ignition. Um, The only difference is the pressures have increased from maybe 12 is to 1 compression ratio. We've reached 22 is to 1, 26 is to 1 compression ratio. Apart from that, nothing else has changed. We have the same sort of differential. We have the same sort of gearboxes. Everything is the same. So we as an industry are lagging really far behind. It is a moment. Unfortunately, we are unable to. No one in the industry is able to see what the future is, and maybe someone like Elon Musk or another future Tesla, will come and disrupt our market also. We never know. But if you ask me, what are we doing into industry 4.0? I'm sorry, I'm still in industry 2.0 right now, and trying to grasp my head around it.
Okay.
I hope I've answered.
that's been honest. Okay.
Yes. It's the truth. I know nothing. Okay.
Okay, fine.
Yeah.
We are still mainly dependent on human labor in terms of this fabrication and everything. Understood. Okay. So next question is also one very interesting question again from Vinod Surange sir, that he wants to know what is the risk management scenario in Indian industries, and do industries follow ISO 31000 standard, which is dedicated to risk management?
Yes. Okay. See, we do not follow the ISO 31000 as of now. There are only two primary standards. There are actually four standards which the automobile industry follows. At the very basic level, we follow the ISO 9001. Currently, it's a 2015 version. So ISO 9001 2015. If the industry produces an output which is polluting in nature, they also have to follow ISO 14000 or 14001. Fortunately, we don't produce any harmful or polluting gases or polluting chemicals. That is why we can get away with following only ISO 9001 2015. There is a QS standard which was briefly used by many companies in the automobile sector. And currently now a lot of the automobile companies are moving to the TS 16949 standard. The TS is a standard which has been created by the automobile companies for the automobile companies. And it is a very stringent standard. My company, BFMC, follows we are TS 16949 certified. And now, obviously, TS has become IATF. So it is the IATF 16949 standard. But Bharat Coach, because we have a wide variety of models, we are unable to certify ourselves for TS 16949. I'll give you a difference. What is the difference between ISO 9001 and TS 16949? ISO 9001 is a company level certification in terms of documentation. It is a quality assurance that you do what you write, you do what you write, and you write what you do. So basically, you make certain policies for your company, you make certain guidelines that you will adhere to, and you have to ensure you create evidence for following those policies. And whatever new practices you make, you ensure you start documenting that. That is all what ISO 9001 is in a nutshell. IATF 16949 is 10 steps further. What it says is each product that you make has to be certified, and there is a certification process you have to go through. Unfortunately, we do not have a standardized project. We don't have one type of model that we make. We make, as I told you, 109 different models across 23 different countries. So we do not know which model I'm going to make next month. That's something which is really difficult to guess. I told you the demand of any product is very erratic. So taking all of this into consideration, we are unable to go in for TS 16949 certification right now. If we have lesser number of models, if we have a more definite idea about standards, if BS6, Bharat Stage 6 does not become Bharat Stage 7, it remains Bharat Stage 6 for a decade or so, then we can think of going for TS certification. Otherwise, ISO 9001 2015 is perfect for where we are right now. Yes. I hope that has answered the question. Thakre sir?
Yes, sir. Actually, there was a cleanse in the network. Yes. Okay. So we'll take the last question. Actually, it is very much related to mechanical engineering.
Yeah, surely.
From Mr. Rishikesh Mahimkar. Why aren't the buses are designed considering the aerodynamics and few other such stuff for much higher efficiency?
Oh, yes. So I didn't get the gentleman's name.
Rishikesh Mahimkar.
Rishikesh, a beautiful question. We are trying to move from slightly from a very unappealing, boxy design to something which is little more curvier. So if you look at the screen right now, what I'm presenting, we have taken out certain elements which are aerodynamically not important, which are aerodynamically detrimental, which are bad aerodynamically, and we have created smoother edges. We have improved airflow in certain areas, uh, and it is a thing that we are trying to achieve slowly and steadily. However, any aerodynamic effect is does not come into play when the vehicle is below 70 kilometers per hour. So if any vehicle is traveling below 70 kmph, the effect of aerodynamics is not of a highly aerodynamic vehicle with a less aerodynamic vehicle is not too much. There is no much difference between them. And considering a bus, most of the buses are staff buses, school buses. These vehicles travel short distances, frequent braking. They don't have an opportunity for too much of speed increase, and therefore aerodynamics does not play an important part over here. Because of this, we have primarily not concentrated too much on it. We have done the bare minimum what is required. We have smoothened out the glasses. We have given a nice contour, a nice curve in the front of the vehicle. There are very few obstructions which are from the sides of the vehicle to prevent airflow. Even the rear view mirrors are designed with this to keep in mind. A lot of basic care is taken. However, it is not, we don't put as much effort as what is required for an automobile, for a car, in a bus, primarily because of the speed constraints. We don't have high speed, so we don't worry about it too much. However, there are foreign companies which are doing great jobs in this. If you look at Neoplan, it's a European automobile manufacturer. They have they take special care to ensure that their buses have a nice curved roof, and it is far more aerodynamic. However, in India, only things have changed recently with the golden quadrangle, with the roads that Modi ji is making right now, Mr. Gadkari ji is making. That is increasing the road speed, and with this in the future, I'm sure we will see vehicles which are more aerodynamic, which are much better looking in terms of a drag. And yes, in the future we will have a lot of this coming across. But as of now, we will be slow over it. But in the future, I see this as a big change happening. Yeah. Good
Yes,
question, sir.
great.
Good question.
Yes, sir. Great. Yes, actually, in relation to this, we have a query from Durgesh Patel, sir, which I am going to answer. That
Yeah.
Durgesh Patel, sir, is asking when design-related session will be organized or when it will be coming. So, sir, actually, I am glad to inform you tomorrow itself. The session that we have organized, it is by one of the certified trainers from SEAMS, Powai. SEAMS is a Center for Excellence in Maritime and Shipbuilding, which is a Government of India enterprise in association with Siemens India. So one of the trainers from there is going to address the session on product lifecycle management and its effect on productivity,
Wow.
productivity improvement in a mechanical engineering scenario. So tomorrow itself, we are having a session which is related to not just design, but product lifecycle management itself using Siemens software tools. Because we had so many industrial interactions, we also have thought about one software session because that is also very essential to reduce the product life cycle. So tomorrow itself, that session will be at 2 p.m. Yes, sir. So, sir, Ruben, sir, this was the last question from this session.
Okay.
On,
That's
on behalf of St. John College of Engineering and Management, as well as Mechanical Engineering Department, I express my heartfelt gratitude to take time out of your busy schedule and having delivered this session so fluently and so precisely and yet comprehensively for our audience. And that I can see that session has been fruitful from the feedbacks that we are getting on our live YouTube chat. So thank you very much, sir.
Oh, thank you so much. Thank you so much. I'm glad I could be of use. I have. I'll just quickly put down my. Just a second.
Yes, sir.
Yeah. I've put down my email ID there, and I request any of you all, if you have any further doubts, if we could not take some of your questions here, you can just send me an email on rbuthello@bharatcoachbuilder.com, or you can visit our Facebook page, Bharat Coach Builders. We are there. I respond to any message I get pretty quickly, and usually on the same day. And if you want to visit our factory, if for an industrial visit, or if you're just keen, you like to see buses, you want to see how they're manufactured, or you want to apply certain techniques into your own line of work, we are absolutely open. We are not worried. Even if you're a competitor to us, we don't worry. We look at it as a collaborator. Please do come visit us. And if I can be of service to you all, please do let me know. Thank you so much. It's been great to be here. Thank you, St. John Institution, for this opportunity. Thank you, Dr. Thackeray. You've been a fabulous host, and you've been helping us out throughout. Thank you. Thank you.
Yes, sir. Thank you very much. So I declare this session to be officially over. Let us meet tomorrow at 2 p.m. Again, the link for the session will be shared at 1:45 p.m. So tomorrow we will be having a session on product lifecycle management using Siemens softwares. So till then, everyone, please take care of yourself and your family. Thank you, everyone. Good day.
Thank you.
Good day, sir.
Good day.